So, for my part of this project, I was in charge of looking at the agricultural needs of a population of 10,000 people on Mars. The first thing that I looked at was how much land is needed per person in order to grow food that can sustain them. And according to the permaculture forum that I looked at, it's about 4 acres per person, which adds up to 40,000 acres. Next, I looked up the amount of people that would probably be needed in order to take care of that much land, and it's just around 80 farmers would be effective as long as they have the right equipment. Next, the important factor was water and fertility of the soil. So according to NASA, the soil on Mars is fertile enough for food growth, although they say that if there was actually going to be a population on Mars, they would need to bring fertilizer to boost the fertility of the soil and help the plants grow. Water was actually probably one of the most limiting factors of the entire process, because every other day the land would need to be covered in 1 inch of water, and in order to cover 40,000 acres in 1 inch of water for for an entire year every other day, it would take approximately 198 trillion 767 million 280,000 gallons of water, which would have to be delivered to Mars. After looking at this number and considering the weight and amount of fuel needed for transportation, I determined that the best way to transport it would be to space out deliveries once every 2 months. So not take all the water at once, instead space out when you send it. Also, for irrigation, the land would have a central sprinkler, and on the sides of that sprinkler, the land would be sloped downwards into retention troughs that would maximize water retention through runoff.
Hello. When it comes to the atmosphere of Mars having an effect on humans being able to inhabit it, it's actually very apparent that it's almost impossible for humans of this day and age to be able to live on Mars. Because if you look at it from a biological standpoint, our respiratory systems would not be able to handle the large amount of carbon dioxide that is on Mars. The atmosphere of Mars is actually about 95% carbon dioxide, and because of this, that's one of the main products of our respiratory system, or our functions because of our respiratory system. Because it's 95% carbon dioxide and it's less than 1% oxygen, is about 0.07% oxygen, to give an approximate. It's basically impossible for us to step on the Mars surface and breathe. It's literally impossible. We'd have to have some type of suit or some type of connecting tube to a large supply of oxygen to be able to breathe on the surface for a couple of minutes. And that's not even taking into account the freezing temperatures, because not just only the atmosphere is uninhabitable because of the amount of gas, but because the atmosphere is so thin, it's actually about, I think, 90% thinner than Earth's atmosphere, which means that there's no greenhouse gases to trap in heat from the sun. So on an average day on Mars, it's about negative 80 degrees Fahrenheit, which is impossible for a human to stand on, in a shirt or a hoodie. It would take some type of very special suit to be able to even withstand those cold temperatures. Near the poles in the wintertime, it gets to about negative 195 degrees Fahrenheit. So it's just basically impossible. But because of these freezing temperatures and because of the large amount of carbon dioxide and small amount of oxygen that's available on the planet, it would be virtually impossible for humans to be able to live on there. And that's not even taking into account the amount of effort it would take into terraforming Mars to be inhabitable. They say about 3.5 billion years ago, you'd be able to trace the water that would be able to be on the surface of Mars. So 3.5 billion years ago, you'd be able to see maybe rivers and things on Mars. But because of the radiation that's happening because of the sun and because of the the solar winds, it just slowly stripped off and peeled the atmosphere of Mars, leaving what we have now, which is an uninhabitable planet. Because there are still small traces of water, but they're extremely difficult to get, and they'd probably be frozen because of the freezing temperatures. So overall, it would probably take either literally creating an atmosphere that can trap in greenhouse gases, or that can trap in the heat, like having a greenhouse gas effect, which would take who knows how long. Like, that's something that I wouldn't be able to predict how long it would take for that to be able to be made. Or we could just find ways to warm the climate, like they said that you could paint it like a darker color, or use materials, dust and plants that are of darker colors to absorb more sunlight to warm the surface. And
So for our project on Mission to Mars, I was tasked with finding a suitable habitat and building materials to create these habitats for humans that could potentially live on the planet. So the problems I have encountered with this is that transporting materials from Earth that we know, such as like concrete and steel, one, they're too heavy, two, it's very expensive to transport stuff from Earth, three, we don't know how it's going to fare in the environment of Mars. Like, it could have certain chemical reactions with the atmosphere, and it might not protect humans from the harmful aspects of the atmosphere in Mars. So there are two solutions to this. One, transporting lighter, cheaper materials to the planet from Earth, or two, create the habitat on Mars by using the planet, by using what the planet provides, such as the rocks that they provide. So the first solution is transporting lightweight material, and this I found on NASA's website, where they propose creating an ice dome, which is, so they have like a inflatable round molding, so that they will surround by ice water, kind of like an igloo, but it's like this way you could see through it. This allows in natural light into the habitat, and it also protects from the sun's rays. And to keep the temperature constant for the ice water to remain so it doesn't melt, the temperature inside the house created has to be maintained at a certain temperature. And then the second solution I explored is using natural resources. And there is a lot of sulfur in Martian soil, and using this sulfur as a binding agent, separating the sulfur and melting it, and using it as a binding agent with like Mars soil, can create a concrete that is actually stronger than the ones we use on Earth. However, this has a downside, as sulfur is very vulnerable to fire. So homes can burn down easily when they are built out of this concrete. And also, then there's another solution for using Mars material. So compressing regolith, or another word for like alien rock. So in this case, rock found on Mars. So compressing this rock will take a very short time, so a very quick building process. So it'll be using heat and pressure to press this rock into bricks, and this way it allows for very quick construction of habitats on the planet, so humans can get settled as quick as possible.
My part in the Group 4 project is to make a breathable environment for surviving on Mars, or rather a developed like model for it. And the two specific methods of getting plenty of nitrogen and oxygen available for creating a breathable environment on Mars would be fractional distillation and using gold foil and blasting carbon dioxide at the gold foil. blasting carbon dioxide at the gold foil, it splits up the carbon dioxide molecule and creates solid carbon and oxygen gas after splitting the bonds between the carbon and the two other oxygens, and the oxygens like form a bond themselves, and that creates oxygen gas. And this method can be used to make like plenty of oxygen gas, like if there's a plenty of carbon dioxide abundant. And then there's fractional distillation, and that is the separation of different types of gases in order to create a specific, like it's the separation of gases within an atmosphere in order to like isolate a single type of gas. So you can use that in order to make just an abundance of nitrogen gas to bring to Mars. And as long as you have a ratio that's somewhere around like 4 to 1 or 3 to 1 of nitrogen to oxygen, then it'll be a much more suitable breathing environment for humans, because our air is consisting of 78% of nitrogen gas and 21% of oxygen. So it's not 100% oxygen. We actually need an abundance of nitrogen as well as oxygen, and we need to have it in a correct ratio in order for humans to be able to breathe and breathe comfortably. So overall, fractional distillation and blasting carbon dioxide at gold foil would be suitable methods for creating a breathable environment for living on Mars.
For my portion of the Group 4 project, I will be discussing the food sources that we would encounter in trying to survive on Mars. And my portion of the part, I discussed what the importance of food, as we as humans can only last a certain number of days without consuming food. If we're on a strictly on water diet. And what I learned from research is the biggest idea behind us having food on Mars is that we will end up having to eat meat made from laboratories and grow vegetables in tunnels that are found on Mars. But complications that come with that is from the lab portion, the lab produced meat would the lab produced meat would get genetically modified, so it lasts longer, which means a bunch of chemicals would be injected into this meat, which would cause variety of problems. And the main problem I talked about was that it could cause health problems and diseases, because we wouldn't know what kind of chemicals we'd be intaking in our body, and how greatly it would affect the different systems within our body, especially the digestive system. And then when it comes to the vegetables grown in the tunnels, yes, it's a very smart idea, but at the same time, we'd have to do extensive research on the different soil in the new area. Try to make sure we're not growing vegetables in in the environments that could potentially modify the vegetables we eat. Same with the meat, messing with the systems in our body because of different chemicals used to produce these new foods. and but main focus was discussing the right diet for the survival on Mars. How it's important for us to have consume carbohydrates, lipids, and proteins. Proteins help with producing hormones and testosterone, and then both carbs and lipids give us energy storage, lipids being the long-term ones, and then carbohydrates the short-term. And that's my portion of the group.